So let us now find out. So right hand side is sine a sinusoid. It has to be summation of sinusoids of same frequency. So we assume VOT as one of the sinusoids, and I am sure that its differential has to be also a sinusoid of same frequency, right? So both must be sinusoids. This is sinusoid, then this has to be sinusoid. So let VOT equal to this, its differential is this. Now I just add these two terms on the left hand side. So what I get? dVOT by dt, that is, and while adding, I think I can add, these are to be added, I will fill up cos terms and sin terms. So for cos terms what I get? What are the cos terms? B plus omega A cos omega t plus A minus omega B sin omega t, and that is equal to sin omega t. It is as plain as that. So now unknowns are A and B, equation is 1, but this can be very easily solved, that they are sin terms and cos terms. So sin terms must be equal, cos terms must be equal. So on left hand side there is cos term, on right hand side there is no cos term. So what we must have? B plus omega A equal to 0, and the terms are A minus omega B, and the A multiplied is 1. So A minus omega B equal to 1. So what is now based? How do we proceed further? How do we proceed further? What is that? How do we? There are two simultaneous equations. Multiplying second equation with I will multiply with minus omega. I multiply with minus omega. Is it right? I multiply. I think I will keep it as it is first. What is that? A minus omega B equal to 1. I multiply this with minus omega. So what I get? Minus omega A plus omega square B equal to omega square. Then I add these two. Equal to, minus omega. Equal to, minus omega. I multiply with minus omega. So minus omega A plus omega square B equal to minus omega. These two I add. When I add these two, omega A gets cancelled, and B plus omega square B is equal to minus omega. So that gives me B as B is minus omega upon 1 plus omega square, and that gives me A as 1 upon. Is it right? Is it okay? So when I put that, my final answer is VOT is B, that is minus omega upon 1 plus omega square cos omega t plus 1 upon 1 plus omega square sin omega. This I can write it using your 12th trigonometric knowledge as a square plus b square under root. Right? That is what? What it is? Under root a b square plus a square, 1 plus omega square. So 1 upon 1 plus omega square comes out basically. 1 upon 1 plus omega square comes out. And in the bracket what I write? Minus omega cos omega t plus so what I get here now, this is simple, a cos omega t plus b sin omega t, that is equal to 1 upon 1 plus omega square as it is, a square plus b square under root. So I get under root 1 plus omega square inside and what? A sin omega t plus b cos omega t. It is actually a sin omega t plus b cos omega t. Final answer we get in sine. If we can get final cos also. Only thing is that for phi is different. Cos omega t and sin omega t are different by simple pi by 2. So here it is sin omega t plus tan inverse of a upon b, that is it right? Only thing is that whether plus or minus you just verify that one. It's okay? So this is viewed. Now what we find, there is one more simplification, that this is under root, this is full, so it comes as it is 1 upon omega or omega. Are you sure? Or b by? There is a question of your trigonometry knowledge. So you have to verify both things, 1 upon omega or minus or plus. But ultimately what we get, this is undoubted, means this amplitude is undoubted, right? So what happens? When omega is less, what will happen? The denominator will be less. So total number of amplitude will be more. As omega increases, what will happen? As omega increases, denominator will increase. As denominator increases, what will happen? Amplitude reduces. And I think you just verified later, this is maybe omega. So it goes away in phase. So original means later on extending it further, you can plot, you can use computer utility. Now there are so many animation programs, you can pick one of them. You can plot input and output would be attenuated and phase shifted waveform sinusoid. Input of frequency omega, output is attenuated and phase shifted sinusoid of omega. The attenuation will depend upon omega. Less omega, it is 1 upon under root 1 plus omega square sine of omega t minus tan inverse omega. So as omega increases, denominator will increase, total number will be less. So if you increase frequency, means amplitude will reduce. Input of amplitude 1 output amplitude will reduce as you increase frequency. On this also I will provide you some other this concept of, this is called as low pass filter. On this concept also we will elaborate in detail in the next lecture. Today we will engaging after lunch break as well. Kutla? Ask. See how much, what you can say, joyous he is in telling that lab is there. Anyway, so we finished today. We have ample time next week also. So, with this we got a solution. When a sinusoid is applied at input, at the output you get a sinusoid of same frequency of reduced amplitude and shifted phase. The amplitude of input is 1, phase it is sin omega t is 1 sin omega t plus 0. 1 sin omega t plus 0, right? So, amplitude 1, phase shift 0, we get attenuated output, amplitude less than, if omega is 0, it doesn't matter, it is a DC signal, we know that. As frequency increases, reduced amplitude and shifted phase. So, you can plot what is called as frequency response, in which amplitude response and phase response. So what is amplitude response? Omega and 1 upon under omega square. And what is phase response? Phase response is at omega 0 and minus tan of omega is minus pi by 2. This angle. It is C sin omega t plus pi. And minus tan of omega is pi. So this is what we get. Now he has raised an interesting question. Till means now, every time I used to say that differential equation is there, so a differential equation is not complete unless constant of means, unless constant of integration is provided, differential equation can't be complete. So, what you can think over it? It's a differential equation. So, I said that answer is B cos omega t plus C sin omega, plus A sin omega t. I said that B cos omega t plus A sin omega t is the answer. Now my question is, can I add a constant of integration in that? If I add constant of integration in that, what will happen? Anyway, at least everybody understood that what is takeaway from today's session. Number one, we worked for a circuit which we have already discussed. We worked for a circuit which we have already discussed. Now, if I have values as R and C, we will getting different answer. Here we are taking them as 1 and 1. So for given circuit, a simple differential equation, a differential term whose multiplier is 1 plus original term whose multiplier again 1 equal to input, and that input is sin omega t. Right hand side being sin omega t, being a sinusoid, sinusoid has to be a sum of sinusoids of same frequency. So I conclude that the solution must be a sinusoid of same frequency. A sinusoid of same frequency is defined by two constants, magnitude and phase, and omega is given to me. So I said it to be either b cos omega t plus a sin omega t. I assumed I started, or I could have started also with c sin omega t plus phi also. In that case, I would have obtained c and pi as. You can also cross verify. You can start with c sin omega t plus phi, differentiate it, it becomes omega c sin omega t plus phi, and then try to add. Then that addition needs expansion. The addition needs expansion for you, and in that because it becomes you omega c cos omega t plus phi plus c sin omega t plus phi. So something sin to something cos, again it's a huge trigonometric calculations. So ultimately you get into a sinusoid, and that sinusoid is of same frequency obviously, whose amplitude is function of input frequency and whose phase is also a function of input frequency. मी आता पुन्हा मराठीत सांगतो. RC सर्किटला जर सिनुसॉइड इनपुट दिलं तर आउटपुट हे त्याच सिनुसॉइड त्याच फ्रिक्वेन्सी सिनुसॉइड असतं, पण इनपुटची एम्प्लिट्यूड एक असेल तर आउटपुटची एम्प्लिट्यूड ही in terms of omega, amplitude is function of frequency and output phase is also function of frequency. So it is a frequency dependent circuit. An RC circuit is a frequency dependent circuit. For a given sinusoid, it produces sinusoid of same frequency of different amplitude and different phase, and amplitude and phase are functions of input frequency. And obviously here I have taken amplitude as 1. Now if input amplitude is different, that will also reflect. So rather than saying output amplitude, I go for ratio, that is gain, amplitude of output upon amplitude of input, that is called as gain. So that gain is function of frequency, and here I have started with phase of 0, I can start with different phase. So ratio of output amplitude upon input amplitude and difference of output phase minus input phase. So gain, amplitude gain and phase shift both are function of frequencies as plotted. Amplitude gain and phase shift are plotted as frequency response. Now I never said nobody except him asked. What about? What are you doing? I never said, nobody ever asked, what is VO at t equal to 0? What is VO0? VO0 discussion did not come in our thing at all. So how we look at it? Right now what it comes as? Right now what it comes out to be? Now we take, let us say, we make it simple further. Let us make omega equal to 1. So we apply sin t. So if omega equal to 1, what that is VO, VT. What is VOT? What is VOT? What is, forget about the phase, this one. What is, no, even if, what is A? A is, omega is 1, so this is 1, right? Omega is also, this is 1. So I write the term here. We know that it is 1 upon 1 plus omega square into bracket minus omega cos omega t plus sin omega t. Omega equal to 1 will make it 1 upon root 2, right? 1 upon root 2. This is minus 1. This is minus 1 omega t plus sine minus 1 cos t plus sine t, right? So it is sine t minus cos t. What it is? In the remaining?
1 by 2.
Where? Oh, sorry. Half sine t minus cos t. Is it okay? Now, at t equal to 0, what is the answer? It is minus half. At t equal to 0, it is minus half. So, what we solve? Then you may say I am contradicting myself. The differential equation is solved without starting condition. How I can correlate these two things? Differential equation has multiple solutions. So the solution which I proposed is one of them. Differential equation has multiple solutions. Solution proposed by me was one of them, and that is providing me half sine t minus cos t. Solution of differential equation does not indicate that it will be existing. Now you need to think at a larger level. What is differential equation? Is a condition imposed between not absolute values of the variable, but the difference in values of the variable. So I may propose a solution, but that may not like that. Somebody else may propose some different solution. So a differential equation has got multiple solutions. Out of them, which exactly will exist depends upon the initial condition, which we are not yet specified. Let you think for remaining 2 days. We discuss on Monday. I think we are having a lecture on Tuesday. So by that time, I will put the videos of this semester as well as earlier one. I think it's enough today. And since